Good morning, everyone. I'm Chris, and welcome back to another episode of Rift Amps. Now, a bit of a case study today. I've got this Soldano. It's the Hot Rod 100 Plus model. It's coming up on. In fact, it's over 30 years old. He thinks it's into 1991, and it started when he said when it gets hot, it starts to cut in and out. He said you start to hear it crackling, and then the volume fades quite quickly, and then will come back in and out and in and out like so. So he's dropped it in for repair. So I've already had this on the test bench, had it running for about 20 minutes, and then yes, fault confirmed, it did start to drop in and out. I managed to get 120 watts of clean power from this thing and well over 200 watts of maximum power. So this thing is running really healthy. I mean, it's running great, but when it's up to temperature, it starts to cut in and out. When it was doing so, I was just giving it a bit of a tweak on the knobs to see if anything affected them, and I think it's this. I think it's the master control, or at least that seemed to cause some issues, but he says it does it on both channels, so maybe it's something downstream of that, I don't know. So first job then is to remove the chassis from the cabinet, and then we can give it a good visual inspection to see if there's anything obvious that might give us a diagnostic direction. So this is one reason I really like these 90 Soldanos, in that they are just built like absolute tanks. I mean, huge transformers, nice thick chassis with welded corners, I think. Really sturdy. That's a Schumacher, I think, 606. You know, I have seen other amplifiers that are newer than this that haven't stayed in this sort of condition. These things are just built to last, which is really impressive. And inside the chassis, we've got a main PCB board with all the components on, the pots and the preamp valves. The output valves are on separate sockets with flying leads running to them. We've got a choke inside the chassis, but you can tell just by the lead dress and the way they've built this thing, they really cared about making a good product. I love these. I think they're great. Okay, so initial inspection. I don't really see anything that's too much of a concern, but we'll have a look and see if we can spot something. So what's my plan of attack of this? Well, there's nothing obviously burnt or broken that I can see. So our next stage will be to plug it back on the test bench, inject a signal in the front end, and we'll trace it through. I have checked, and there is a schematic for this model online, which is good. We can trace the signal through, and once the signal starts to drop out and it's running hot, we should be able to find exactly in the circuit where that signal drop is occurring, and that will help us locate where the issue might be. Okay, so running on the bench, that's our output sine wave, currently doing 30 volts into 8 ohms. That puts us about 112 watts. Quite happily do more than that. So we'll just leave this running. That's the schematic on the iPad. So we'll just leave this running. We'll get it hot, and then we'll use the other probe on the oscilloscope to trace through and see if we can find out where that signal is dropping in and out. Right, it's just started doing it. So you can see it's jumping around. I'm not touching the amp. I'm not doing anything. But you can see it's doing that. All on its own. Isn't that interesting? So, Now that it's hot, if I get my chopstick, let's start tapping around. See if we can get it to drop out. It did it then. Problem is, it's so intermittent. I don't know if my tapping actually fixes it or not. It was around here. See? Right. Okay, so the purple trace is the input. I'm scoping directly at the input. And the yellow trace is the output. And if I hit the board, you can see the output is affected. Add it then. There you go. But the input isn't, so the fault is further downstream. So let's look at this schematic then. We've got the input here, which is where I'm currently measuring. Let's go to the other side of this cap and see where we end up. So we're now on that cap, and you can see the signal is still further downstream because the yellow is being affected. But the purple isn't. So what I'm going to do is I'm going to keep following the signal path through the amplifier until I find the point where both signals are affected, and then it's got to be upstream of that. Okay, starting to dial in on it now. I'm just looking at I found a point in the circuit where we're measuring on the send side of the effects loop, and if I make the amp play up, I can get it to cut in and out, look. But our input signal stays the same. If I come to the return side of the loop and I do the same, both signals drop out. So we've certainly nailed it down to the send and return section here in the effects loop. Have we simply just got dirty sockets? I think so. So how can I prove that? Well, what I want to do is I want to discharge the amp. I'm going to remove these two nuts, pull the loop out, give it a good inspection, see if we've got corroded or burnt pins on the sockets, because it's quite common for those to start playing up and then you start getting your signal drops out. Let's try that, shall we? So here's the loop board. I just sprayed it with some deoxit, Servicol, and given the terminals a quick clean as well. We'll put it back together and see if that where the issue was. Okay, so the amp has now been running soak testing on the bench for about 3 hours now. It's had since I cleaned the effects loop jacks, and it's been rock solid. No issues whatsoever. I can't get it to play up anymore. That was our issue. So, I hope this helped explain one way that you can diagnose an amplifier that cuts in and out, using a signal generator and an oscilloscope. Simply follow the signal pass through until you find where the signal is disappearing. Back up a bit, find out where it is. That helps you zone in exactly on the circuit where the issue might be, and then you can investigate further. I didn't have to do any voltage measurements, any resistance checks, nothing like that, just simply using a 2-channel oscilloscope and a signal generator. So all I'm going to do now is I'm just going to check the bias and then leave it soak testing for the rest of the day. We can reassemble it into the cabinet and we can then call this one quits. Well, that's it then, guys. Thank you very much for watching. I hope you've all learned something. Please give this video a thumbs up, like and subscribe, all the usual stuff. Put some comments down below. I do read them all and I do try and reply to them. And I shall see you all at the next one.